Okay, so now let's come to the capacitor on an AC circuit. In an AC circuit, we need to remember that the capacitor does the absolute opposite of an inductor in an AC circuit. So this capacitor still has the property of reactance. We'll come back to that in a second. But it does the opposite to an inductor, so they behave quite opposite. What that means is, with a capacitor in an AC circuit, the current will lead the voltage. So here is the voltage peak, 90 degrees. The current will reach its maximum 90 degrees earlier. So the current's going to reach its maximum 90 degrees earlier. So that means that the waveform for the current will do something like this. Okay, so not the prettiest, but it'll do. So we can now see that the current starts 90 degrees ahead of the voltage. So there's the voltage peak, there's the current peak. And this is caused by the reactance of the capacitor. Remember, inductor and capacitor behave as absolute opposites. So let's just redraw this by using a phasor diagram. So once again, let's start with the voltage. There's your angular rotation. This is the voltage. And in this phasor diagram, the current comes before the voltage. The current leads. So there is the current through the capacitor. So this is the opposite of the inductor where the current was down here. Okay, so the reactance for a capacitor can be found from the formula XC equals 1 over 2 pi FC. So C is the value of the capacitor, F is the frequency. This is opposition to current flow, so it's in ohms. Okay, so once again, Ohm's law will work for us. So V equals I times R. No, V equals I XC. And I equals V over R. No, I equals V over XC. And finally, R equals V over I. It's not R, it's XC is V over I. So this is our variation on Ohm's law using XC to find the reactance of the capacitor. So let's do a very quick example. Okay, so let's have a look at the question and then have a look at the numbers. An 8 microfarad capacitor is connected to a 230 volt 50 Hz supply. What is its reactance? What current does it take from the supply? So part A. Reactance XC equals 1 over 2 pi FC. Put the numbers in. 1 over 2 times pi times the frequency is 50, and then times C, the value of the capacitor is 8 micro. That's times 10 to the minus 6. And if you put that in your calculator, then you should come out with 398 ohms. Okay, so part B, we're back to our variation on Ohm's law. See if I can squeeze it in the bottom of the sheet. Find the current. I equals V over XC. Put the numbers in. V is 230. XC was 398. The current is, if you put that in your calculator, 0.58 amps.